All right. Hey, everybody. Welcome to today's webinar. This is a low impact development online series. This is one of 3 online series. And today's topic is Mission Impossible, keeping permeable pavement permeable. We want to thank our LID online series sponsors today, the US EPA, Arkansas Department of Agriculture, Division of Natural Resources, Beaver Water District, and Construction EcoServices. Let's see here. All right, sorry about that. So I'm your host, Becky Roark. I'm Program Director for the Beaver Watershed Alliance in Springdale, Arkansas. And our guest speaker today is Anthony Kendrick, Project Manager at Construction EcoServices based in Houston, Texas. And I met Anthony back at an EPA conference a couple of years ago and was just really fascinated by all the innovations that their group, Construction EcoServices, is doing. And over the years, Anthony and I have stayed in touch. And he's helped us on a number of projects, including a green infrastructure project we're doing right now, which I'll talk about in a little bit. So we want to thank Anthony for being here today as well. Just a little housekeeping today. So at the bottom of your screen, you're going to see a Q&A bubble. So if you have any questions, please do type it in the Q&A section, and we'll answer those as we go along and have some time at the end for that as well. Also, today's webinar is going to be recorded. So if you'd like to review anything we go over today, or share this with other people, we appreciate that. And today's, we'll send you the link afterwards. So just a little bit about us, the Beaver Watershed Alliance. Our mission is to proactively protect, enhance, and sustain water quality in Beaver Lake and the integrity of its watershed. And we do that by taking a watershed approach. Everything we do is voluntary participation, whether it's working with a farmer out on his property along a stream or helping a city with low impact development. Everything we do is voluntary. We also conduct scientific investigations through water quality monitoring of local streams, and we're constantly adapting, such as today's presentation, doing these online webinars. So a little bit about us. And here you're going to see the White River Watershed. So the light tan area around the blue shoestring, that's the White River Watershed. And the White River actually starts here in northwest Arkansas, down in the southern portion of Madison and Washington counties, and it flows north. And several tributaries run into the Beaver, and form Beaver Lake, one of 3 reservoirs along the White River system. And then it flows into Table Rock Lake, and then Bull Shoals, and then takes a direction west over into the Arkansas River, where it eventually flows down to the Mississippi and the Gulf of Mexico. So we want to be good stewards here in the Northwest Arkansas region to protect this watershed, because it is the headwaters of the White River system. Beaver Lake itself was dammed back in the 1960s for flood control. So over the years, though, it became our central water supply. So Beaver Lake is actually our water supply for 1 in 6 Arkansans here in Northwest Arkansas. And this is a picture of state priority watersheds. This watershed is a state priority because it does have stream reaches that are considered impaired, which means they don't reach their designated use, and they are listed on the 303D list. So there's a number of different agencies and partners working to address these impairments through different voluntary practices. So anything we can do to help improve water quality, to maintain a healthy watershed, is our goal. So on the left here, you see this is kind of a zoomed in photo of the Beaver Lake watershed. And our biggest pollutant is sediment. So most of that is primarily coming around the Beaver Lake area itself, up at the top here. And on the far easterly side of the watershed, the West Fork is also has a heavy sediment load to Beaver Lake. And most of that is coming from stream bank erosion issues, dirt road runoff in rural areas, and as well as construction debris and sediment runoff from development in urban areas. So these are the challenges that we face in our watershed. So in 2017, the Beaver Watershed Alliance applied for a 319 non-point source grant, and that was awarded $500,000 to install 3 low impact development projects in the watershed. So these are basically demonstration projects where we're going to install permeable pavers, bioswales, rain gardens, things like that, along 3 different parking lots in the Northwest Arkansas area. So one of them is going to be at Mount Kessler, which is a ball field in Fayetteville, Arkansas, partnering with the city of Fayetteville. The second project is going in at Hickory Creek Boat Launch, partnering with the Army Corps of Engineers. And the third project for the green infrastructure is going in at Mitchison Park, which is located in Huntsville, Arkansas. So we're really excited to see those being installed this year. Designs have been finalized, and we really look forward to these installations to demonstrate these green infrastructure and LID elements. We also have a number of partners that help us accomplish watershed stewardship. So we want to thank all of our partners that support the Beaver Watershed Alliance and promote healthy water quality for our region. Okay, so next I'm going to hand it off to Anthony Kendrick. And Anthony is a project manager for construction EcoServices, and he received his bachelor's degree in biology and master's degree in environmental science from the University of North Texas. Before he joined Construction EcoServices, he spent 3 years working for an environmental engineering firm. Currently, Anthony manages green infrastructure projects in the Texas and Louisiana areas while assisting the design community and municipalities to implement multifunctional stormwater management solutions. Anthony has a passion for sustainable stormwater practice and that enhances the built environment. He's dedicated to educating engineers and designers in the practice of the next generation of low impact development. So with that, I'm going to hand it over to you, Anthony.
All right, guys. Well, thank you very much, Becky, for the introduction. And today, guys, we're going to talk about how we can use permeable pavement in stormwater management, and then most importantly, what is the best way to keep these systems working? I moved to New Orleans in 2016, and in New Orleans, before 2016, their approach to stormwater management was get the water to the canal system as fast as we can. Let's pump it out and get it out of here. It's more of a nuisance. And so in 2016, maybe early 2015, they did a complete 360. And now all commercial, private development, and even municipal development, their intent is to detain water, promote infiltration into native soils, and then also provide some water quality benefits. So what they're trying to do is more hold on to the water and use it as a resource. And so it plays a lot into how this city has gone about in letting commercial properties do this. And then also they had to worry about maintenance, because if the city was going to have these private developers invest in stormwater management, and if they were going to take tax dollars and invest it in stormwater management, they wanted to make sure that owners were going to be maintaining it. So they actually also implemented a maintenance ordinance where owners are actually having to re-permit their stormwater BMPs and prove to the city that they've been working. And so what that's done, that's going to give me a lot of good information to kind of see what systems work, how do you maintain them, and what are some of the design and construction practices that we can do to kind of help these owners cut down the cost, because the cost to maintain a stormwater BMP can be a burden to some owners, whether it's a surface pond, bioswale, or permeable pavement. And so we'll talk about that today and the different ways you can do that. So my favorite BMP has kind of switched over to permeable pavement. We've been doing so much of this in New Orleans, and in fact, the ordinance here got updated recently to where every parking stall on a commercial development over 5,000 square feet must be permeable pavement. And so for some of these owners who have these large developments, they can have 200-300 parking stalls that they have to maintain. And so as a designer, you have to be cautious as to what type of pavement you use, how you design it, because you don't want to have that owner, pumping lots of money into their budget just to maintain a permeable pavement system. So there's pretty much 4 main types that I see in my area and also in other parts of the United States. The top left picture there, you got your porous pavement, so that could be either concrete or asphalt. I've also seen other type of material used. So essentially what it is the pavement itself is porous, it's like a sponge, and it allows water to trickle through the voids within that pavement. On the top right there, you have your interlocking concrete pavers. So these are just either traditional pavers, or sometimes the pavers will have little bump outs and there's a gap in those pavers and it's filled with aggregate. So that allows that water to infiltrate off the paver and into the joint, which then goes into your sub base. That's also a very common practice. And another thing that I've also seen in New Orleans and also in Houston, this is a pretty big product that they use in the Gulf Coast, are these gravel pavers. So these pavers can be filled with either grass or gravel. It's a very low cost option, and so that's another type of pavement they use. And then on the bottom right picture there, that is an open joint paver. So it's very similar to the concrete paver in the picture above it, but the important thing is the joints where those pavers connect, there is no aggregate. So what that does, that allows that water to have a clear channel down into your subgrade, and basically improves the infiltration rate of the paver itself. And we'll talk about how all these different types of pavements, how they're designed and built, how it affects the maintenance. So the grid structures, you'll see all different types of products for these. The main difference in the different products you're going to see is what type of plastic it's made out of, and also the height of it. So this vendor right here, they name theirs, E30, E40, S50, and really what that relates to is the height of the grid. So the E30 is about a little over an inch in height. The E40 is about 1.5 inches, and then the S50 is 2. And so it's a European company, so they're using millimeters, but and so that's important because that's the height of the gravel that you're infilling. And also the shorter of your grid structure, that's probably gonna be more for residential, while the E40 module, or say if it's a 2-inch paver or 1.5-inch paver, that's gonna be more for commercial and then even heavy industrial applications. So most of these are all pretty much constructed the same way. You're going to lay down a plastic grid and either fill it with aggregate, or sometimes they'll fill it with soil for grass. And the base of them are pretty much all the same too. They're either going to sit on a 57 stone base. Sometimes you can do like a choker course of smaller aggregate, but these work best when you just sit them directly on the 57 stone, because it allows that water to get into your base a lot quicker. And the way that you install these is you don't actually overfill the paver. So you fill the gaps and the voids just enough to where when the wheel load actually traverses across the surface, what you're doing is the load is spread out between the grid structure and the aggregate within it. And we'll talk about why you don't want to overfill your pavers later on, but this is kind of the design intent of this product, is to transfer the load between the grid and the rock itself. Here's a really cool application, I think, of using these gravel pavers. So they're a pretty low cost option. Most of these run like $2 to $3 a square foot. And then they fill it with either some type of chip rock, pea gravel, whatever it may be, whatever you're locally sourced. The challenge for these, we'll talk about later, is the maintenance. You know, since you are filtering your runoff and sediment debris through rock, it can be a challenge to keep it clean. And so the best way to really prevent having to do any maintenance on these or rip them up and reinstall them is when you design them, you really only want to have a 1-to-1 drainage area ratio. So in this project, they do have a little bit of the drive aisles that drain into it, but mostly this is really only accepting rainfall. And they also slope the entire site so that the water, if the pavers do clog, say there's, you know, over time they start to reduce their infiltration rate, there is a stormwater bioswale on the lower side of the property. So what that does is that ensures that, you know, even if the owner doesn't maintain it or the system starts to clog over time, there's a way for that water to get off the property. Because that's always something you want to consider when using permeable pavement, is your safety factors. So you can't always assume the owner is going to do maintenance. You can't always assume that it's installed correctly and that it's going to perform as it's intended to. So you want to build some type of redundancy or safety factor into your design. And what's really good about these gravel pavers is if you want to use traditional pavement next to it or other types of permeable pavers, these work well. You can lay them in together. You can separate them out by curbs. And then you can also use different options. So like I said, I think one of the ways that this product gets installed incorrectly or misapplied is when they end up putting too much chip rock on top. And the reason that's not good is because when the chip rock, the smaller rock, doesn't handle traffic load well. It can actually crush and turn into a powder or a fine sediment. And what happens is that fine sediment thing can then clog the rock voids below. So whenever you see projects where, you know, the grid surface is somewhat visible and then they have like maybe an inch or two of gravel over top of it, over time, what's going to happen is that crushed limestone falls within the voids of the rock, and then it rains. And we all know what happens when you mix crushed limestone with rock, or crushed limestone with water. You get concrete. And so to really ensure that these systems this won't happen, is you got to make sure that your installer does not overfill the pavers. And then also you want to make sure you use a rock. We'll talk about this later about abrasion tests, but you want to make sure you use an aggregate that has enough hardness on it so it can handle that traffic load. So you can see in this picture, this is really, really small diameter rock. So this is probably not the best type of rock you want to use. I've seen 57 stone, I've seen pea gravel, but you probably want to use a little bit larger diameter rock than what you see here. And then what can happen, you know, you get ponding water, and you can kind of see in this picture in the top layer how much overfill they have. And then this is just kind of the result. And so you see this a lot when owners think, you know, oh, the grid surface is visible, we need to put more aggregate on it. But you got to let them know that that's not how it's intended to be. And another issue I've seen is where they will put these gravel pavers in areas where you probably don't want to do it. And so in this situation, this is a restaurant where they put the gravel pavers where the delivery trucks turn around. So this is the only area where a delivery truck can get in and make a U-turn and get out of there. And what happened was this driver accidentally jackknifed and ended up pulling up some of the pavers. So it probably would have been better off if they would have done a traditional pavement in the drive aisle and kept the gravel pavers in the parking stall. So these types of pavers work really great in parking stalls. And then if you do want to use it in a drive aisle or where you have a lot of heavy traffic, you probably want to upgrade to the thicker or the taller module where maybe you have a 2-inch height, because those can actually handle those types of traffic. While the paver they used here was probably more so on the inch or inch and a half height. And so it just makes it really difficult for that paver to handle that traffic load. So our other type of pavement is the permeable interlocking concrete pavers. This is actually one of my favorite applications of this type of paver. This is at the World War II Museum in New Orleans. And you know, I don't know when they installed this, but if you go out there, this is probably the cleanest looking permeable pavers I've ever seen. You know, they only really get pedestrian pavement. They don't actually ever get any vehicle traffic on it. So if you go out there, the aggregate looks really clean. It drains down really well. And they also have different patterns in there. And you can kind of see in the picture on the left, you can still see all the aggregate in there. And you don't see much sediment and debris. And that also attributed to the fact that if you look, there's really not a lot of landscape to really blow in any kind of leaf litter or debris. And so this is a really cool application of these pavers in a pedestrian application. And you can see where they did different types of interlocking pavers. So you have these other pavers where they just use the joints along the edges. And then these other pavers kind of get these, basically the open joint is on the corner of the paver. So there's all different types of vendors out there. And really the big cost you'll see difference between this paver and the gravel paver is really the installation cost. The labor to install concrete pavers is much more than your gravel pavers. There's not as much forgiveness with these when you're laying down. You want to make sure the subgrade's level. So really, we'll talk about the different costs of these systems, but yeah, concrete pavers can be more on the high side. And then, and here's a cool application where the parking stalls actually drain to a drive aisle here. And you can see all the aggregate in those joints. And this project's actually fairly recently new, and it hasn't got a lot of traffic because it opened up shortly before the pandemic hit. So, but they're already starting to see some leaf litter in the joints, and you can see there's a little bit more landscape around here. So they're going to have to really think about that in the maintenance, long-term maintenance of this system is how much surrounding landscape is going to start to clog your system. And this is another really cool paver here. This is what we call a Belgian cobblestone, and so this is a lot cheaper paver. I'm pretty sure these probably cost maybe $1 each or a little bit less, but they kind of have an irregular shape, and they also can be gravel filled. So this is another low cost option that we've seen a lot in the Gulf Coast. All right, so we just got a question. Can the gravel pavers or interlocking concrete pavers be ADA compliant? Yes, so far, all the projects I've seen, they've been ADA compliant. In fact, I know the gravel pavers even have parking markers that you can use for handicap spaces as well. But one thing to consider is over time, if the pavers start to sink or have subgrade issues, or if the owner overfills the gravel pavers with gravel, then they can become out of compliance of ADA, but generally when they're first built, they do meet all those requirements. So another thing to consider with interlocking concrete pavers is, so since you're using aggregate to fill in those joints, they're going to clog quicker than say if it was an open joint. So this is a project where the owner really didn't do a lot of maintenance. They had some construction sediment actually clog some of these pavers. But what happened was they started to get in, you can see basically these interlocking concrete pavers are turning into grass pavers. But this can be an issue with a lot of concrete pavers if you don't maintain them on an annual basis. What's going to happen is you're going to get ponding water. And so, and you can see the water that's ponding in these parking stalls, and this is during a pretty big rain event. It was probably about 4 inches of rain we got that day. You can see that pattern matches where all the grass is filling in these joints. And so that's something to consider. Most of the time you want your permeable pavement to drain pretty quick, especially if it's in parking stalls, because if you're going to have parking stalls and it takes an hour or 2 hours for that water to finally infiltrate off the surface, well, that's going to be difficult when you want to have people park at your place when and they end up stepping in the water. So we'll talk about the maintenance frequency, but interlocking concrete pavers do, I think they do hold up better than your gravel pavers, but they do require annual maintenance to make sure that they don't end up becoming a nuisance. All right, our third type of permeable pavement is our porous pavement. So here, this is the porous concrete that they actually have at the Beaver Watershed Alliance, their main office. And the good thing about permeable concrete is that the entire surface is permeable. So with the interlocking concrete pavers, we really only have the joints. But with this type of pavement, you do have a lot of surface where you can infiltrate water. So that's good because it kind of takes care of your design safety factors, because you have that whole footprint to permeate water. Now, the difficult thing with permeable concrete is the installation process. So it's much different than traditional concrete. So the way permeable concrete is actually, or I think the same goes for porous asphalt, is the reason it's able to soak up water is they actually remove a lot of the fines. So concrete gets a lot of its strength from the rebar and all the fines that they put in there. With permeable concrete, you don't use any rebar, and you also take the fines out. So in order to counteract that, those items actually provide structural strength. You actually add a binder, a chemical binder. It's almost like a glue, and what that does is that binds all the loose aggregate together while still allowing some voids and open spaces for that water to travel. And so when you install permeable concrete, you need to make sure you have a lot of the right conditions. You can't do it on a super humid day. You also have to make sure that the concrete cures for over a week. So they actually have to cover it with a visqueen layer or an impermeable layer for a whole week to make sure it cures. And if it's not installed correctly, you will have some issues. And so what I've seen on a lot of projects is you'll see certain parking bays where the permeable concrete looks really good. And then other areas where, let's say the conditions weren't right, or the contractor might've got hurried, their schedule, didn't allow them to have as much time to install it. And they'll start having issues where the concrete actually starts to ravel off. And so here's a project where you go out on the site and a few of the parking bays look really great. They perform great. They're getting about 800 inches an hour as the infiltration rate. And on the same project, one parking bay over, the permeable concrete looks like it's falling apart. And so I think a lot of those inconsistencies, it's going to take a lot for contractors to make sure they're very consistent, but this is some of the risks that you're going to get with permeable concrete. If you don't have an installer who's really good at this or who specializes in this, you're going to have areas where the binder and the glue, maybe it was too hot that day or it was too much moisture in the concrete. There's a lot of factors that could contribute to this, but what happens is that binder and glue ends up actually breaking down over time. And I think here along the Gulf Coast, we have a lot of issues with this. And I think that has to do with a lot of the fact that we have, high temperatures, it's very humid, it rains a lot. We have a lot of vegetation and landscape that can clog it. And so what happens is we see a lot of binder and glue breaking down, and you can actually see where the parking stripe almost disappeared from the site. And so that can be a challenge, and that's something you want to consider in your design. And you can kind of see here where there's like a little texture difference in the bottom left of the picture and the rest of it, where that top layer starts to ravel off. So that's the process where the aggregate just starts to become loose. And this can become an issue when you get certain areas that ravel, and then what happens is that becomes a lower spot in the concrete, so you get a lot of fines that get in there, and so those areas will tend to clog. And so when it clogs, you'll get this ponding water. And then also, if the contractor uses too much binder or glue when they're installing it, they can actually permanently seal off the concrete. So in the picture on the right, you can see there's standing water. So you got the gutter edge and you got the permeable concrete next to it, and there's just standing water directly on it. And that has to do with the fact that it was just not installed correctly. And so it's pretty simple and easy to see if permeable concrete has too much binder and glue. So this entire parking lot is permeable concrete, but if you look at these parking stalls, they have these really white splotches everywhere. And what that is, that's actually where too much glue and binder was used. So if you go up close and look at it, you will see, the loose aggregate around that red circle looks like there's some open pores, but if you look at this aggregate, it's completely filled with that glue. So there's no way for that water to infiltrate. And so that's something you're gonna have to look for after installation. And the challenge with, porous pavements is, say you install it like this and it doesn't look good, it doesn't, the owner doesn't like it. Well, it's a lot more difficult to pull this pavement up and reinstall it compared to like a gravel paver or an interlocking concrete paver. Interlocking concrete pavers, you can pull them up and reuse it. But with this type of pavement, once it's in, you're pretty much stuck with what you got unless you can really force the GC or the subcontractor to fix the problem. So that's something to consider in your design, is if you're kind of unsure of the skill of the labor of installing it, that might be something you want to consider. And you can kind of see some of the raveling issues. This is probably the worst case scenario where raveling has pretty much wiped out this whole handicap sign. You can't even tell that's a handicap spot anymore because all the gravel has just become loose. All right, so our next type of pavement is our open joint interlocking concrete pavers. So there's only a few products on the market that we've used over the years. And these are a little bit thicker. So this particular one's about 4.5 inches thick. But what these do, these interlock with each other. So it's almost like an articulating concrete mat. And you can see they have little bump outs. And then there's an open joint. So that gap that you see between the pavers is about 1/4 inch, which is ADA compliant. And what that does, that allows that water to go directly into your subgrade. And now another benefit of having an open joint is now you have more room to store your sediment. So if you have a lot of sediment in here, you still have a lot of open joint space where that water can migrate into other joints and then down and below. So one thing that you'll see with open joint pavers is they're a little bit more resilient. So they can take on a higher sediment load and still perform to a pretty good degree so that they can get all that water off the surface. And so in this situation, this was a medical center we just installed last fall. And what you can see here is we actually have a 4-to-1 drainage area ratio. So this entire parking lot only has one drainage inlet, and all the surrounding impermeable pavement that you see, that concrete, all drains to these 2 parking bays. And so this allows that designer to really take advantage of basically using the paver as an inlet, right? So they're using it as a catch basin, right? They're allowing that water to infiltrate, and they're also getting detention. So below that paver sits about 18 inches of aggregate subbase. So that's all the detention volume. And the good thing about these pavers is once they're installed, you can drive right on them. So with any type of concrete paver, and those gravel pavers, once they're installed, you can go ahead and start using it. And you can see these pavers are set directly on top of your 57 stone. They work pretty good. This is actually a picture I took right during the middle of a rain event, and you can see that water does not pond on the surface. It gets down in those joints fairly quickly. And another good benefit about using this type of paver is that the high infiltration rate allows you to minimize your footprint. So you can see in these 2 examples where we have maybe a 2 or 3 foot strip of these pavers, and then we're just capturing sheet flow. So if you're doing a retrofit project, or if you want to promote, some type of BMP, but you don't want to, you still want to use traditional pavement, this is another good way of doing it. In fact, you can also use this on roadway projects. So we have a couple of roadway projects in New Orleans where we call it a green gutter. So instead of doing a traditional curb and pan gutter, you can add this 2 or 3 foot strip of pavement, and allows that water to infiltrate before it reaches your catch basin. There's other types of pavers. So there's this one. This is actually a plastic grid, and then you put these little brick pavers in it. And if you look, there's these open joints along that grid surface. So this is another open joint paver, but it's also a plastic grid paver. So this is another unique application. And I like this paver because you can use it with your traditional either gravel pavers, grass pavers, or even traditional pavement. And what's really great is you can change the colors of the blocks so you can get really decorative. And so this is another cool application, and you'll see this a lot where they'll do your permeable pavers where the wheels get on the parking stalls, and then you got your grass in between, because the grass tends to grow better when you don't get vehicle traffic. And so when you do have grass pavers, I think a good benefit is to use these hard surface pavers where the wheels come on the parking surface, and then just let the grass grow in the area where they're not getting much tire traffic. I think you'll get better results when you do it like that. So here's some of the installation costs. So this is kind of the installation cost of all your permeable pavers. Your gravel pavers and your porous concrete are going to be on your low end. So these are your more economical types of permeable pavement. They do carry a higher risk of maintenance and installation errors, but overall, I see a lot of this used just because it's very economical. But I think a lot of owners long-term are gonna end up, the money that they end up saving up front, they'll probably end up spending, maintaining these systems to keep them permeable. Your interlocking concrete pavers and your open joint pavers are gonna be on your high side. And a lot of that has to do with just the labor. So most subcontractors or paving contractors are gonna charge you anywhere from maybe $7, maybe up to $10 a square foot just to install a paver. So some of these pavers can only cost $2, $3, $4, but then they end up making up most of the cost is the labor itself. So that's something you have to consider. But long term, the open joint pavers will definitely save your money long-term maintenance. And then the interlocking concrete pavers do require annual maintenance, but they do they'll hold up a little bit better than your other types. And we always recommend when we do maintenance proposals or budgets for engineers, your joint filled interlocking concrete pavers, your porous pavements, you want to do an annual maintenance on those. And that can cost anywhere from $1 square foot to $1.50 a square foot. And so if you have a 5,000 square foot permeable pavement, that's going to cost that owner, they want to budget $5 grand a year to keep that permeable pavement working. And then your open joint interlocking concrete paver, although it does cost more to install, some of these projects we've gone 5 to 7 years with no maintenance. Our oldest installation we did was approximately five years ago, and it's still doing really well, and we haven't had to maintain it. Now the gravel and grass pavers, they're difficult to maintain. Really, the only thing you really want to do is you want to replace any kind of aggregate that ends up getting tossed aside, or say a wheel. Whenever you get the vehicle traffic, it'll shift some of that aggregate out of there. But once some of those pavers start to fill up with debris, it's a little bit difficult. So mainly on the grass pavers, you're more maintaining the gravel itself and making sure it stays within the grid than so much of you're trying to clean it to promote infiltration. And I'll show you how we maintain these systems. And then what do you consider, like, when you're talking about a schedule of maintenance? First thing you want to look at is drainage area ratio. So if your permeable pavement's only accepting rainfall, well, that's going to be good. You're probably not going to get a lot of sediment and debris. And then if you have a lot of surrounding landscape that's going to drop leaf litter on there, you want to take into account that, because that can actually bump up your maintenance schedule to twice a year. And then obviously your type of permeable pavement. And then more importantly, what we see a lot is you'll combine these permeable pavements with some type of detention system below, or they're trying to infiltrate water into the groundwater. So if you're doing something where you're doing flood mitigation or flood risk, you want to make sure that you maintain that permeable pavement more often, because if your pavement starts to clog, well, then there goes your detention volume, there goes your infiltration. And so you want to make sure that if your permeable pavement's doing that, you definitely want to be on top of your maintenance schedule. Now, the biggest killer, or the biggest challenge, I guess, with permeable pavement is construction sediment. This is the #1 killer of any type of stormwater BMP. You heard Becky earlier saying that their #1 pollutant is sediment. And if you go to any construction site, you're likely going to see contractors, not really paying a lot of attention to the sediment runoff. And this was actually one of our first permeable pavement projects that we came upon in New Orleans. And you can kind of see where the contractor put an inlet device on the catch basin to keep sediment out. But look at the pavers. They have dirt all over them. All those joints, they're just completely filled up with dirt and debris. And so most contractors don't really understand that the permeable pavement is also an inlet. Okay, we got a question about how these systems work in snow and ice. I know most of these systems do really well in freeze and thaw because you have so much void space where the water can expand in the subgrade and also in the joints of the pavers. And I know the gravel pavers, they use a lot of those up north, and they hold up pretty well with freeze thaw. In fact, you can actually take some of your permeable pavement and heat it up. There's actually one vendor who heats up their permeable pavement to melt ice, so it's kind of cool. But I don't think freeze thaw is too much of an issue as long as you have plenty of room in your subgrade, and your pavement has those open pores in there. And so you'll see a lot of times contractors will want to install these permeable pavers, when they do the pavement, but sometimes their landscape comes in afterwards, and so you'll still have a lot of loose sediment debris that washes off your landscape islands. And you can kind of see here, all the parking bays are just completely filled with sediment. So this system hasn't even got a chance to work yet, and it's already been clogged. So what we like to do is cover that system up with fabric. And this is a situation where the next door neighbor was doing a construction site, and their silt fence got knocked down, and so all the sediment washed onto the adjacent property. And so that's a little bit unfortunate, but those are some of the issues you have to worry about with permeable pavement. And here's another project where this was actually one of the largest installations of permeable pavement I've ever seen. It's got about 250,000 square feet of porous concrete. It's a very large mega church that they got out in New Orleans. And you can kind of see the permeable concrete is getting a lot of sediment and debris. So if you look at that drainage inlet on the right, here's a close-up view. They're just allowing all this sediment and debris just wash onto that permeable concrete. And so some of these areas are probably already completely clogged, and it can be difficult once they clog like that. Sometimes it's really difficult to maintain them to promote infiltration back. Sometimes they completely fill up with sediment. You really can't do much about it. And so what we like to do is when you install your permeable pavement, we actually cover it up with a filter cloth. So just like you'll see a lot of contractors will put geotextile cloth over the drainage inlet. Well, you can do the same with permeable pavement. So this is a project in Houston where we installed all the permeable pavement in this is kind of like a townhome where they have all the condos and with the drive aisle in the middle. And so we knew that they were going to be doing a lot of building for the residential units, and they could potentially get sediment on there. So we covered up our entire system here and to protect it from getting clogged. And it works really well because you can still drive on it, you can do whatever, and then at the end of the project, they just rip off that fabric, and they got clean permeable pavement underneath. All right, well, we'll move on to some of the design considerations. So one thing you want to consider is when you're doing permeable pavement is your soil bearing capacity. So what that really is what kind of traffic load can that soil handle? So a lot of times you're working with soils that are either weak or clay soils that will tend to soak up water and swell or shrink. And so that could be a challenge for permeable pavement. So the first thing I recommend is have your geotechnical engineer look at your soils report and make a subgrade recommendation. So your geotechs are already usually looking at your soil, making a pavement recommendation for the concrete or the building foundation. So it's not much more for them just to go, okay, well, if we're going to have permeable pavement, how thick should our base be? Should it be 6 inches? Should it be 2 feet? I think the worst case scenario we've seen is 2 feet, but I've seen a minimum of 6 inches, and the soil will hold up pretty well. And subgrade failure is pretty common with most types of permeable pavement. And so here's an example where the grid structure started to settle next to the curb, and so you'll see this with interlocking concrete pavers and other types, and you can kind of see here where the inlet stayed up high, but then the pavers are starting to settle below. And then here's an example where kind of hard to see where the dip is, but if you look at the parking stripe lane, you get a curve. So you definitely don't want to see a curve in that line. That just kind of shows you where when the vehicle comes off that traditional pavement and then drives onto that permeable paver, that's where it gets a lot of the load comes off of that, and so it ends up creating a dip right next to the interface of your traditional pavement. And so, in fact, there's one city in North Texas where they were using a lot of these permeable pavers, but a lot of the contractors started skimping on the subgrade. They were just using the bare minimum. They weren't really looking at, using a thicker base. So the city started seeing a lot of issues like this where they're getting subgrade failure. So they ended up just removing this BMP altogether from their stormwater ordinance because they just didn't want to deal with these issues. But I don't think that's always necessary. I think if you talk with your geotech, you can do a subgrade that's not gonna settle over time. And another thing to consider is your curbing. So a lot of times these systems are either butt up against traditional pavement or they'll have a curb around it. So we like to use usually like a header curb or a ribbon curb where it might be 12 inches deep and 6 inches wide. And the reason you want a hard surface there is so when that traffic load comes off that paver, you want it to hit a hard surface. You don't want it to have just loose aggregate next to the paver because that can then start shifting that subgrade below, and you'll end up, that's where you get the dips or the subgrade failures. And then also, if you look at the different types of subgrades, so most of the time we'll just install like a 57 stone base, or maybe we'll install like a larger stone diameter in the bottom, like a number 2, number 3 stone, and then we'll do 57 stone on top. Pervious concrete and your open joint pavers can sit directly on top of that 57 stone. While if you're going to use like an interlocking concrete paver, you're probably going to use a choker course or a bedding course. So this is your smaller rock, like number 8, number 9 stone. And I would rather use just 57 stone because it infiltrates faster. Sometimes that bedding course can restrict the flow. So you'll want to make sure that you're not using too fine of a bedding course. You want to have some type of void in there. And then also you'll want to consider what type of subgrade or geotextile you use. And so, you know, whenever we use aggregate, you know, we're sourcing it locally. So some places, I think it's up in Indianapolis, they get a lot of soft limestone. And so you want to make sure you get limestone that has a hardness value, or what we call a Los Angeles abrasion test. And that's all it's doing is that tells you, you know how sturdy, how resilient is that aggregate? Is it going to crack under traffic loading, or is it going to hold up? So one thing that you can do is you can request your contractor to give you an LA abrasion test and a gradation report. So a gradation report will let you know, are you getting a lot of fines in your aggregate, or does it meet the ASTM requirement for 57 base or number 2 base? So putting those in your submittal documents, your abrasion test and your gradation report, I think should be a part of your permeable pavement submittal. It's not just the pavers you're worried about, but it's also that subgrade. And then when it comes to geotextile fabric, we mainly use a woven fabric that we'll put on the native soil before we install any type of aggregate base. And that just kind of helps spread out that load. And then you can also use fabrics that have a grid interlaced with them. So there's actually woven fabrics that will have a plastic grid in it. So that's a little even more sturdy. But if you've ever seen highway construction or pavement construction, they're always going to use some type of geotextile fabric, and that just kind of helps separate your aggregate from your native soil. So make sure you don't use a cheap fabric, go with more a durable one. And then let's talk about some specs. So, the whole is greater than the sum of its parts. A lot of times, contractors aren't going to read specs. They're always just looking at, what's on the plans, and then, hey, is there any type of value engineering, or is there another alternate product that we could potentially use to save us some money? And so it's always important to establish your specs so that, your contractor can build what they want, but still meet your design intent. And so that's what your specs there is, protect your design intent. So here's an example. Let's say you specify an open joint paver. You want it to infiltrate at 1,500 inches an hour, and you want a 10-to-1 drainage area ratio. So you might have a 10,000 square foot parking lot, but you only have 1,000 square feet of these open joint pavers. Well, if your contractor was able to find a cheaper paver, but it's an interlocking concrete paver, well, that infiltration rate is a third of the interlocking open joint paver, and also it has a smaller drainage area ratio. So here's an example where you can see here in the blue box, that was our open joint pavers, and you have a pretty large drainage area ratio, you can see. But if we wanted to use an interlocking concrete paver, we would have to expand the footprint, right? Because our infiltration rate's lower, and we also can't do our drainage area ratio as high. So we have to kind of spread out that footprint. So contractors might not necessarily think about this. They might just think it's an equal swap, but you always want to make sure your specs are to a point where they can't kind of jump out of bounds and end up risking your design intent. And then one thing that we like to do with our specs, so this is actually a spec that we have in our open joint paver, is we will establish when the pavement needs to be maintained. So sometimes you can do like an infiltration rate. So, you'll take 6 random tests of the permeable pavement. If it infiltrates, less than say 200 inches an hour, then you need to maintain it. Also, if your pavement's ponding water, that's probably a good indicator. And so you can write those specs in there. And another thing, if you look at part B of that maintenance, what we do is we actually include a maintenance warranty. So you can do this either through the distributor. So for instance, we'll distribute certain products and we will provide a maintenance warranty. Usually it's 3 years, but sometimes we'll make it longer. And so you can either have the distributor do a maintenance warranty, or you can have the installer. And so you can make sure that they put that in the budget. And what that does is that really keeps that owner, gives them a little more, comfort room and reduces their risk. Because a lot of times, if there's anything that's going to go wrong with erosion or construction sediment, it's going to be, early on in the project. So having that maintenance warranty is really good for the owner. And if it's a municipality, it really kind of helps reduce that risk. And the challenge, this is pretty challenging because, porous concrete, for instance, it's provided by a ready mix company that makes the concrete. And then you have a paving contractor who buys it and installs it. So, so far I have not seen anybody do a maintenance warranty for porous concrete. But for the open joint pavers, we do that. And then you should be able to find some type of distributor who would do that for the interlocking concrete pavers. And another spec that we also like to do is your infiltration rate. So if you're going to spec in a permeable pavement, well, I think 1,000 inches an hour is a good baseline for most types. So porous concrete, you can achieve this. The gravel pavers, you can get pretty close. I think gravel pavers usually hover around 800 inches an hour. The open joint pavers can definitely meet this. The interlocking concrete pavers have a little more of a challenge. They're generally around 600 to 700 inches an hour. So you can always, I think probably baseline, I wouldn't specify anything less than 500 inches an hour, because one thing you got to consider is, over time that infiltration rates can decline. So if you start at 500 inches an hour, it could take some time before it gets down to 0, or say 1,000 inches an hour. So make sure that you specify an infiltration rate as that as well. And you can see there's also a freeze thaw resistance in that spec as well. All right, let's move on to maintenance. So there's different types of ways to maintain it, but it all kind of boils down to having, who has the most powerful vacuum. At the top, that's a regenerative air machine, or a lot of people know them as street sweepers. Street sweepers aren't necessarily going to do a good job maintaining your permeable pavement. They're really good at keeping debris off the surface, but once the joints or the pores start to clog, those machines just don't have enough suction power to pull out all that dirt and debris. And so there is a company, Elgin, they make this really cool vac truck called the Whirlwind. And instead of it just having like a baseline vacuum system, this has a vac head on it that can suck up, I think, 20,000 cubic feet per minute. And so you can kind of see it there right next to, on the bottom left, next to the tire, that's the vac head attachment. So what they'll do is that truck will spray water, it'll run the brush, and then they can just suck out, either if it's an interlocking concrete paver, they'll pull out all the aggregate, and then you'll sweep it back in. Or if it's an open joint paver, you just got to drive over it. It's only a one-step process. But you can also use this on porous pavements as well. So this is kind of what the truck looks like. We got to see a couple demos of them. The only downside of this, you don't see a lot of these out in the market, and they're pretty expensive. So if it's a maintenance contractor, they would have to have a lot of permeable pavement to maintain to afford this truck. And if it's a municipality, you know, they're not necessarily going to have these types of trucks because, you know, they might not have enough permeable pavement to clean. But what you can do is attach vac heads to your standard Vector trucks. So so most cities will have these Vector trucks that have a what we call a hydro excavation unit. So it's that you see that water hose on the front of the truck, and then they'll also have a big suction hose coming off the top. So what this does is they use these a lot for sewer cleanouts, but you can attach this vac head, and this vac head will be able. What you do is you pump water from the truck, and it ends up has like a wand that spins, and it's pretty much like a high pressure car wash. So what that does is that water will lubricate all the joints. It will kind of pull up some of that sediment, break it up, and then the vac hose will then suck up all that loose material out of those joints. And this works pretty well. You are kind of limited in your footprint. You know, it's a little bit smaller than the vac head on the Elgin Whirlwind, but this works great when you don't want to buy a specific truck. You can just, you know, these things cost $8,000, so you can retrofit your entire fleet for a lot less than buying a new truck. And we've used these on different types of pavements. We've used it on the porous concrete. Here's some that we used. This is a city here next to New Orleans that installed some permeable concrete, and they wanted to test it out. And we've also done it. This is porous asphalt. And so what's really interesting about this is we did a little demonstration for City Park, and they had you know, a lot of I don't think they ever maintained their porous asphalt. And so they had a lot of sediment and debris piled up into the low part. So we came out there with a vac head, cleaned, like, you know, we partially cleaned this parking bay, and then it just started pouring down rain. So when I drove by it, you can actually see the footprint of where we cleaned. And so you can kind of see water ponding around it, and then you see these little areas where the pavement looks dry because the water's just. So these vac heads can work pretty good. But again, if you wait too long to clean your pavement, sometimes these vac heads always can't necessarily resurrect the pavement, but they can do a pretty good job if you have a regular maintenance schedule. And then here we go, we're using it on a interlocking concrete paver system. So on this project, what happened was the general contractor ended up getting some construction sediment on the concrete pavers. And so the designer, before they handed the project over, the designer had them come out and do a vac head and clean out the first, maybe half inch of those pavers to get that sediment out. And then one thing to consider is that when you do interlocking concrete pavers that have the aggregate, it's a two-step process. So you have to suck up all the aggregate, purchase new aggregate that's clean, and replace it back in there. So it can be a little bit more maintenance intensive, but nonetheless, we can still maintain that type of pavement. Here's a worst case scenario. So this is a project in Houston where we installed these open joint pavers, and you can see the general contractor pretty much treated our pavers like a dumpster. There was nails in there was lumber, pieces of wood, and there was probably like maybe a 1/4 inch of sediment over the entire system. And so we spent 2 days out there with this vac head, and we also had to use a high pressure hose because there was so much debris in these joints that it took 2 full days to clean this, which it really should have just taken less than 1 day if we did it on a normal maintenance interval. But this kind of shows you that if you don't provide sediment protection during construction, you know, you can really put yourself in a bad situation where you're not going to be able to keep those pavers, get them back to where they should have been. All right, okay, let me show you guys some case studies that from around the globe or the United States. This one's actually up in Michigan. This is called Keeler Street. So this is actually a retrofit project, I believe, where they did a traditional asphalt pavement in the drive aisle, and then they retrofitted the gutter. I believe it's about 4 foot wide, maybe 5 foot wide, with these open joint pavers. And what's really cool about this is there was an engineering firm that did a little maintenance case study. And so you can kind of see, look at all the trees in the landscape. So this is a residential neighborhood. So it didn't take long for all the grass clippings and the leaf litter to just clog the joints of these pavers. So this is a paver that infiltrates at over 1,000 inches an hour. But again, you know, if you have a high sediment load, high leaf litter load, this is what ends up happening. But what's really cool about this is a year later, they came in and did some maintenance. So they got that vac head attachment that I just showed you and cleaned up all this permeable pavement. And then if you look at the results, so Keeler Street, the 2 locations they tested, that was all the open joint pavers. And then the Artesian Street, that was actually a porous asphalt portion that they did. So if you look at the before cleaning, on Keeler 1, it was at 200 inches an hour. Keeler 2 was almost to 0 right there. 49 inches an hour isn't that much. But what's great is you look at the infiltration rate after they clean. Keeler Street was able to get up on the number 1 location to over 1,000 inches an hour. And then the number 2 location got close to 1,000. So what that shows you is when you have these open joints, it makes it to where the system's a little more resilient to clogging. You can restore its infiltration rate back. And even some of the porous asphalt, even though they didn't get you know, as high as an infiltration rate, they were able to bump it up 1 order of magnitude from 20 to 320. So so these vac heads can be effective, but again, you have to be diligent about your maintenance schedule and when you want to maintain them. And then here's a cool little case study. This is one of our first projects we did in New Orleans. In fact, I think the engineer who designed this is actually on this webinar. So what we did here, this is a combination where we did open joint permeable pavers with an underground detention system. And I really like this project. I live nearby it, so when it rains really hard, I get to go out and take photos. And you can see, if you look at the landscape over on the left, there's probably 2 or 3 inches of water in that mulch bed. But if you look at the pavement, it's draining pretty well. So the challenge with this project was that we really didn't have a lot of footprint. So that building took up most of the footprint of the lot. And there was about 1,200 square feet where they could do detention and permeable pavement. So we ended up excavating out a large portion right here, about 2 or 3 feet deep. We ended up installing an R-tank system, which is just an underground detention system. It was wrapped in filter cloth, and then we installed the open joint pavers right on top. So what you're seeing here is the installation process. It's a pretty small site, very congested, but at the end of the day, we're able to solve the problem. And now one of the issues we had was the contractor, for whatever reason, didn't pour curb on this edge over here. And so they ended up just putting a piece of lumber. And so like I said earlier, you know, curb details are important. And what happened was after they installed it, they backfilled some aggregate behind the boards to kind of hold it up. But that's not very permanent. And so they actually had a maintenance vehicle drive up next to here, and it ended up actually crushing part of the board and making some of the pavers settle. So we had to come back and repair this. But that's always important to make sure you have that curb detail around it. But overall, it's done really well. I believe we installed this in, I think it was 2017, 2018. And so far we haven't had to do any maintenance. If you go out there, there are some leaf litter in the joints and all that, but it really hasn't affected the performance too much. And then I wanted to show you this case study. This is an example of how you can use permeable pavement with, like I said, with an underground detention system. But this is more of a multifunctional system. So this particular property was a corner lot on a bigger retail development, and they didn't have enough room to do a detention pond. So they had to go underground. And so what they ended up looking at first, obviously, was an underground detention system. And if you know anything about underground detention, it could be pretty costly. So they were looking at maybe $10 to $12 a cubic foot to detain their detention volume. So that's, you're looking at a $300,000 price tag for the owner. So instead, the designer ended up combining a small bioswale in the kind of in the right-hand corner there. And then they used these open joint pavers. So they had about 2,500 square feet of permeable pavers. But that larger area that I have highlighted, that's actually an entire 7 inches of concrete base. So, or sorry, not concrete base, but aggregate base. So instead of doing a detention system, they spread out the aggregate subbase. So they counted all the voids within those rocks. So that all had traditional pavement, and then these other areas had just these permeable pavers, which acted kind of like your drainage inlets. And so there's kind of the cross section of what we did there, but and then there's the bioretention cross section. But what I wanted to show you the importance is the cost of the system. So one thing about Harris County where this project was done is they'll let you do a reduction in your detention volume if you do a low impact development design. And so they ended up cutting down the cost of their stormwater management by a third by integrating bioretention, permeable pavement, and aggregate subbase for storage. So if you go out there, all this concrete you see right here has a 7-inch layer of aggregate where they store stormwater, and off to your right there, there's the actual open joint paver. So that's actually what captures all the stormwater. And then where those curb cuts are, that actually drains into a bioretention system. So they were able to take advantage of some surface storage, some underground storage, and some permeable pavers to end up cutting down the overall cost of the system. And another good thing I like about using permeable pavers is combining them with trees. So, you know, we all know that urban trees don't do too well, right? They don't like compacted subgrade. They can damage your utilities or actually upheave some of the pavement. So you'll see a lot of people use these structural soil cells. So what they do is they provide the load support for your pavement while allowing all the soil that the tree uses. It's uncompacted, healthy, and so what it does, it allows that tree to reach its full maturity. But in this particular project, we installed some permeable pavers on top of the soil cells. So now when it rains, the voids in that soil will act as a detention, and then the trees can help soak up that water. And so it's another good way of combining BMPs and really taking advantage of your entire landscape. People don't often think that trees can be used for stormwater management. But if you have enough trees on your site and you use these soil cells and permeable pavers on top, you can get all of your required detention volume in the soil if you really designed it correctly. So this is another good benefit of doing this. And we've done this on a couple other projects. They're usually either roadway projects or city projects, but it's another good way of combining those BMPs. All right, great. Well, it looks like that's all I got for you guys. So if you have any other questions, you know, feel free to either email me or go through the chat. And then I don't know if Becky has it to where we can do an open discussion, but if you do have any other questions, you know, feel free to reach out to me or Becky. You got my number and my email down there. And we also have some more written up case studies if you want to learn some more in-depth stuff about some of these projects that I discussed today.
Excellent. Thank you, Anthony, so much. That was wonderful, and I know I learned a lot. If there are any other questions, please chime in. Otherwise, I'm going to move over to a final slide here for everyone. So. Okay, so again, thanks, Anthony. And we want to thank everybody that joined in today for today's online series. Again, this is a 3-part series, so we would invite you to come back next week on Wednesday, May 13th. We're going to have Anthony back again with us to talk about multifunctional stormwater design with vegetated systems. And we're also going to have Eric Fuselier with Craft and Toll. He's going to be talking about some native plants that are suitable for the Ozark region to integrate into your low impact development or green infrastructure projects. And then on Wednesday, May 20th, we're going to talk about where have all the ditches gone, the value of bioswales as stormwater detention features. So we're looking forward to these next 2 presentations coming up, and really appreciate this high value, great content presented today with you, Anthony. And just to wrap up here, if you have any questions for Anthony, he did share his email. And for any questions or to learn more about the Beaver Watershed Alliance, you can reach out to me, Becky Roark, Becky at beaverwatershedalliance.org. Otherwise, we hope you all have a great day, and thanks so much for joining us.